Boom! Alright folks, how are you going? Hume again. So in this video, we're going to get straight into some more trigonometry in the C-Sec Admat syllabus. In this video, we're going to talk about the Pythagorean identities. Now the syllabus itself specifies one, but what I would do in this video is go through all of them so that you get a clear sense of the procedure, the steps. Alright, and the hope is that by seeing the same procedure repeated with some slight modifications a number of times, it would help with the memorization of the whole thing, right? Remember, my guiding philosophy is to get you to understand as much as possible. And once you understand, remembering will be less of a tricky proposition. All right? So we go to our good friend Pythagoras' theorem. And we know from the outset that Pythagoras' theorem says that h squared, which is the hypotenuse, is equal to the opposite squared plus the adjacent squared. All right? So in other words, the square of the hypotenuse is equal to the sum of the squares of the other two sides. We know that by heart. Now, there are three things that we can do to this particular equation to manipulate the equation so that the equation itself would change form. The appearance would change, but the essential value would remain the same. So let us start by dividing this entire equation by h squared. All right? So you divide by h squared. All right? You divide the entire equation by h squared, and what do you get? You get, suddenly you have now that, and we're going to write it here now, h squared over h squared is equal to o squared over h squared plus a squared. In fact, no. I'm going to write it in proper algebra. Right? H squared over h squared will be equal to o squared plus a squared all over h squared. All right? So we divide the left side by h squared. We divide the right side by h squared as well. How are we looking now? H squared divided by h squared is 1. This is the same thing as o squared over h squared plus a squared over h squared. All right? And of course, o squared over h squared is the same thing as o over h squared plus a over h squared. So 1 is equal to over h squared plus a over h squared. Now, we know that o over h, opposite over hypotenuse, is sine of theta. All right? And similarly, we know that, let me bring this a closer to the line here. We know that, I'm looking like a 9. I make it more h now. All right? Right. We know that a over h is cosine of this same theta here. So what we now have here is that 1, therefore 1 is equal to sine theta, sine squared theta. Well, again, let me make it very clear in terms of how I write this thing. So we're saying that 1 is equal to the sine of theta squared plus the cosine of theta squared, which is the same thing as sine squared theta plus cosine squared theta. So therefore 1 is equal to sine squared theta plus cosine squared theta. And this now gives us the first Pythagorean identity, which is that sine squared theta plus cosine squared theta, sine squared theta plus cosine squared theta is equal to 1. All right? So that is the first Pythagorean identity. Pythagorean identity simply meaning that the identity is derived from Pythagoras' theorem. All right? So now it doesn't matter, of course, whether I put cos squared plus sine squared or sine squared plus cos squared, because we know that addition is commutative, meaning that the order doesn't matter. Cool? So whatever you prefer to put first in terms of the order, makes no difference. So that is the first Pythagorean identity. So we could tuck that into the corner here as identity number 1. What color ink to use, boy? Let me go with the red now, just for the contrast. So identity 1, we could say that I will normally write cos squared first. So I say cos squared theta plus sine squared theta is equal to 1. Cool. So we're going back to this fellow here to derive a couple more. Right, so we're going to rub off this. So even with the big board, we still have to use the eraser. There is so much of these things to write, so much information. Right? Yeah? Right. So in the first instance, we divided by h squared. So now we're going to switch things up a little bit, and instead of dividing by h squared, we're going to now divide by o squared. All right? So we divide by o squared. We divide by o squared. All right? We divide by o squared and we get what? H squared over o squared is equal to o squared plus a squared all over o squared. All right? And we're going again. This is the same thing as h over o squared being equal to o squared over o squared plus a squared over o squared, which is the same thing as h over o in brackets all to be squared. This is a o, not a 6, being equal to 1. Right? O squared over o squared is 1 plus a over o in brackets all to be squared. Now, here's where we're going to take it a little further than the CSEC AdMath syllabus. We're stepping into Cape Pure Maths territory now. But I'm doing it here for two main reasons, as I would have explained earlier on, just so you could see that the process is not just some one-off thing. Okay, we started off by dividing by h squared. We could also divide by o squared. We could also divide by a squared. All right, and when you divide by these two, you give rise to two further Pythagorean identities, which, even though the AdMath syllabus doesn't explicitly mention it, it is good to be aware of it, because you may find yourself with a tricky question to solve and be able to use one of the other two Pythagorean identities, in which case they wouldn't not give you the marks because they use a Pythagorean identity that is not explicitly mentioned in the syllabus. All right? So a little extra knowledge, when appropriate, doesn't hurt. All right? So h over o. We know that o over h is the sine of theta. Right? Which means that h over o is something else. H over o is 1 over sine theta, right? Which is something else which we refer to as cosec theta, all right? So 1 over sine theta is cosec theta, so in this case we will get that cosec, hold on, we get that h over, this will be cosec theta squared is equal to 1 plus, and a over o, we know that o over a is tan theta, opposite over adjacent, so a over o would be something else, which is 1 over tan theta, which is equal to cot theta, cotan, right? Which is, so cosec theta squared will be equal to 1 plus cot theta squared. And of course, when we get here now, we'll get that cosec squared theta is equal to 1 plus cot squared theta. All right? And this is another Pythagorean identity. This one is we normally write this one as identity 3, but the order in which you write it doesn't really matter. All right? So 1 plus cot squared is equal to cosec squared. That is another identity. So let me write that in the corner here too. All right? So I'm putting that as 3 because I want to slip the other one in as 2. Just a matter of personal preference. It doesn't really make any difference, any substantial difference at the end of the day. So I'm putting that one in as, I'm putting this one in as 3, which is to say that 1 plus cot squared theta is equal to cosec squared theta. That's Pythagorean identity 3. So let me go to Pythagorean identity 2 now. Right? So we go back to our Pythagoras theorem. We're rubbing off again. So you see it's the same process. The same process. The only thing that changes is the quantity that we're dividing by. That changes, and naturally as we change that, everything else will change. But the essential procedure is the same. And this is something that I wanted to get where mathematics on the whole is concerned. Right? Generally, you'll have a system of procedures, right? A system of steps. And in a lot of cases, these steps will be the same. You just apply the same steps to different entities, which will give you different results. All right? But the results themselves will be linked by virtue of the fact that you arrived at those different results by virtue of the same process applied to different entities. All right? Yeah, I know it's a mouthful, but I'm trying to communicate the philosophy of mathematics. It is not just about numbers and about figures and about questions in an exam. It's about a philosophy, it's about a way of doing things. It's about discovering how certain things are. All right? You didn't make it, you meet it so. Yeah? Right. So in this case now, we divide by a squared. That is the last quantity we have to divide by. So we divide the whole equation by a squared. Is that a, not a u? And what do we end up with? We end up with h squared over a squared being equal to o squared over a squared. Sorry, I'm making the same mistake again. This is what happens when you're so familiar with something that even when you have to teach it, you forget sometimes that you have to break it down into small bite-sized chunks. So a squared over a squared will be the same as o squared over a squared all over a squared. Right? I want to take some pains to make sure this thing is legible. Right, over a squared. So we come here now and we say that this h squared over a squared is the same thing as h over a, all to be squared, as a h over a, which is the same thing as o squared over a squared plus a squared over a squared. Alright? H over a, believing it as that, h over a all to be squared. O squared over a squared is the same thing as o over a all to be squared plus 1. Alright? Now, this is a plus sign, this is not a multiplication. H over a is hypotenuse over adjacent. Alright? We know that a over h is the cosine of theta, which means that h over a is something else, which is 1 over the cosine of theta, which is sec theta. Alright? So this here is sec squared theta. We're making the same mistake again. This is sec theta in brackets all to be squared. Sec theta in brackets all to be squared being equal to O over A is opposite over adjacent, that's tan. So that's tan theta. Tan theta. Make a better theta than that now. Tan theta, all in brackets to be squared, plus 1. Which will leave us now with sec squared theta being equal to 1 plus tan squared theta. And this is what I prefer to write as identity 2. So up here, I would slip in that 1 plus tan squared theta is equal to sec squared theta, right? No particular reason. The only real reason why I put it in that particular order is because you start off with the entity that you're familiar with, cosine and sine. You have tan here. So you introduce sec here for the first time. And then in the third identity, you have cot, cotan, and cosec, both of which are entities that most admat students wouldn't be familiar with up to this point. All right? Now, the admat syllabus specifies this guy only, but it is really kind of difficult to avoid these other two if you're considering this. And you'll get a sense of that based on the process that we use to derive all three of these things. All right? So my humble suggestion is that even if you don't memorize these two, that by seeing the process, right, you would understand that apart from this, we have something else out here as well. And if you want, you could start with this guy and divide this equation by cos squared. In fact, let me actually do it so you can actually see what I mean when I'm saying what I'm saying. All right? So let me rub off everything. Hold on. Let me get this duster here. All right? Whew, yeah, boy. Yeah, the vagaries and the vicissitudes of writing out stuff on the board and talking about it. All right? So, all right. So, let us take our good friend here. So we can do this. We can say, okay, we're starting off with cos squared theta plus sine squared theta is equal to 1. Let me divide the whole equation by cosine squared theta. All right? So you divide by cosine squared. Cosine squared. You divide the whole thing by cosine squared theta, you'll get cosine squared theta plus sine squared theta is equal to, let me put it, right? All of this over cos squared theta is equal to 1 over cos squared theta, which is the same thing as cos squared theta over cos squared theta plus sine squared theta over sine squared theta, which is equal to 1 over cos squared theta. All right? This, of course, is equal to 1. So we're going in this direction now. So we get 1 plus, this is sine squared over cosine squared. Right? It's equal to 1 plus sine theta over cosine theta. Being equal to 1 over cosine squared theta is, this is squared, eh? Is equal to 1 over cosine theta squared. Right? Which is equal to 1 plus tan squared theta being equal to 1 over cosine is sec squared theta. Alright? So, if we divide by cosine squared theta, we get this guy here. And again, we do the same thing for sine squared and we get the other guy. So, again, alright, we're rubbing off here. And we're going to do the same thing. We start with the same equation. But instead of dividing by cosine squared, we divide by sine squared. Alright? So we divide by sine squared now. All of this over sine squared theta is equal to 1 over sine squared theta. Alright? Which is equal to cosine squared theta over sine squared theta plus sine squared theta over sine squared theta, which is equal to 1 over sine squared theta. And we come in again now. Cosine squared over sine squared is cos theta over sine theta squared. Sine squared over sine squared is 1. And this is 1 over sine theta in brackets, all to be squared. Cosine over sine, if we know that sine over cosine is tan, then cosine over sine is 1 over tan, which is cot. So we get that cot squared theta plus 1 is equal to 1 over sine is cosec squared theta. All right? Cosec squared theta. And that is identity 3. So when you start with cosine squared plus sine squared is equal to 1, which we can derive by dividing Pythagoras' theorem by the square of the hypotenuse. So in other words, we start with h squared is equal to o squared plus a squared. Hypotenuse is opposite squared plus adjacent squared. We divide everything by hypotenuse squared. Right? And we do that, and we end up with this. And from here, we could take the approach now of dividing by cosine squared. In one case, dividing everything by cosine squared. And in the other case, dividing everything by sine squared. We could do that and get these two, or we could come over here and just divide everything by opposite squared and divide everything by adjacent squared. And that is how we get the Pythagorean identities. So, as we just would have mentioned it in the course of working there, let me just put it out on the board one time. That also associated with all of these guys here is the fact that, and now let me put this as a separate thing. Sine theta over cosine theta is equal to tan theta. This is something that you must know. This is very important. You will use that relationship in a variety of different questions. If you're not sure, let me check it out on this side. All right? We know that, we could use black across here now. All right? We know that over here, using the Pythagorean, we are using the right angle triangle. Hypotenuse, opposite, and adjacent. All right? We know that sine of theta is equal to SOHCAHTOA, opposite over hypotenuse. All right? O over h. And we know that cosine of theta is equal to adjacent over h. So if we divide sine theta by cosine theta, we have O over h divided by a over h. Right? Which will give us O over h multiplied by h over a. Right? We cancel the two h's and we get O over a, which we know is opposite over adjacent, better known as tan theta. Alright? So if they ask you to prove, which they can do that, even though it doesn't explicitly say that in the syllabus. It did mention that they expect students to know that sine over cosine is equal to tan. And if they ask you to derive the relationship that sine theta over cosine theta is equal to tan theta, then all you have to do is put down your right angle triangle, opposite adjacent hypotenuse, sine theta, cosine theta, you divide, bim bim, bam. Alright? And of course, the syllabus explicitly states that you have to be able to derive this fellow over here, which we would have already done in the earlier part of this same video. Alright? So at this point, we can close let me write down them other fellas just as a note. Right? Sine theta over cosine theta is equal to tan theta. Let me say that 1 over cosine theta is equal to sec theta, and 1 over sine theta is equal to cosec theta, right? You may or may not have to interact with these in the course of doing an advanced exam, but there is a pretty good chance that if you take your practice seriously, if you take your preparation seriously, that you wouldn't just be limited to this first identity. And that is the thing about it. Because when I did AdMaths, we had to do all of these three. Now I see on the CSEC AdMaths syllabus that they're only asking for this. But it is, once you're not doing it at a superficial level, it is really difficult to avoid interacting with these two if you're dealing with this guy here. So I put in everything, right? And of course, if sine over cosine is tan, then by default, I want to leave that on the board. It means by default then that's cosine over, it means that cosine theta over, all of this is what has happened to it. It means by default that cos theta over sine theta is equal to cot of theta. All right? So this too we also have to know. All right? Yeah. This is the main one, of course. This guy and this guy. But between this guy and this guy, you'll have to interact with these two, which means that you need to know this, you need to know that, and you also need to know that. Well, 1 over tan is cot. Right. So 1 over tan theta is equal to cot theta. All right? Right. So 1 over cosine is sec, 1 over sine is cosec, 1 over tan is cot. Right? So you could arrange it however you want to arrange it if you're taking notes. And of course, if sine over cosine is tan, then cosine over sine is cot theta. All right? So this is stuff to know if you have any intentions at all of doing pure maths at CAPE in Form 6, then yeah, don't even think about dancing around this even at AdMaths level. Because if you get into all of that, it will put you in a position where you could master these things in terms of solving the identities using those guys in the way that somebody who only sticks to this alone or who only tries to stick to this alone wouldn't be able to do. All right? And of course, when you go into CAPE, you'll also have to prove this and prove this, and the use of these other guys here will be much more frequent. All right? So for some of us who are looking to do pure maths, the AdMaths is where we set in the stage for a higher level of mathematics. For those of us who are not necessarily going on to do CAPE, then we just do it properly still now. All right? Good. So we could close the video now. We can wrap that up. We try to treat the thing comprehensively. I hope that you would have enjoyed it. I hope that you would have been edified by it. And I want to encourage you, as I always do, to find questions to practice. Watching the video and understanding is one thing, but you now have to use the understanding, which is a different level of understanding. You have to do that. Use the information, use the understanding, use the comprehension that you would have gained here in the course of working questions. All right. So let's take care, keep good, and come back for the other videos in this series.